The geometric model for this problem is a right triangle in which the radius is the hypotenuse and it measures 30 centimeters. The wheel is moving forward clockwise, so the revolving rate 10 revolutions per second will be negative. The angle made by the dot and the center of the wheel is theta, and the adjacent side will be x. We want to find dx dt as a function of angle theta. Now, besides 30 centimeters, what's given is the rate of change of the angle theta, 10 revolutions per second. Now, one revolution is 2 pi radians. Therefore, 10 revolutions will be 10 times 2 pi radians. So 10 revolutions will be 20 pi radians. We're just gonna write it as 20 pi. The rate of change of the angle theta can be written as 20 pi per second. Cosine is adjacent over hypotenuse. So cosine theta is x over 30. And when we cross multiply, x is equal to 30 cosine theta. We're going to take the derivative of both sides. 30 times negative sine theta d theta dt. This is the derivative of the revolving angle with respect to time, is equal to the derivative of x with respect to time is dx dt. Dx dt therefore is equal to negative 30 sine theta, and d theta dt is 20 pi per second. So it's going to be multiplied by 20 pi per second. Now dx dt is negative 30 times 20 will be negative 600 pi multiplied by sine theta. And if we want to add up the unit, it'll be centimeters per second. And this is the function of angle theta that we wanted. Now for B, we need to graph that function. Is a graphing utility. So instead of theta, we're going to write it as y equal to negative 600 pi sine x. Now when we press graph, we have a bunch of vertical lines and we can't see the function. So now what we need to do is to adjust the windows, the viewing windows, according to the scales that is appropriate to the function. We know that the period of sine x is 2 pi, and the amplitude for negative 600 pi sine x is negative 600 pi. So the 2 pi scale should be on the x-axis, and the y-axis should be larger than the amplitude, which is the absolute value of negative 600 pi. So the x minimum should be negative 4 pi, 2 period to the left. As soon as I move away from it, it converts it into a decimal. And we'll choose 4 pi for the x maximum. Now the scale, well, the scale will be one of the markers that we use the most in trigonometry. So it's going to be pi over 4, which is 45 degrees. Now for the y, well, the y will need to accommodate the top of the amplitude. We're going to multiply 600 by 4, because knowing that pi is 3.14, so 600 by 4 is 2,400. We will keep the y scale at 1. 2,400 will cover the top of the amplitude, and negative 2,400 the bottom of the amplitude. Here we go. This is our curve. Now we can see it in our calculator. For the next question, we will look at the absolute value of dx dt and determine when it's the greatest and when it's the lowest. We don't have to use derivative for that. We can just use y equal to sine x as our model and determine the top and bottom of the amplitude. The absolute value of sine theta, taken separately, has a maximum distance of 1, which means that sine theta itself is plus or minus 1, and the angle theta is pi over 2, plus n pi, pi over 2, 3 pi over 2, and so on and so forth. And this is the greatest value. Now, that distance will be 600 pi. The absolute value of sine theta taken separately is equal to 0. And that's the lowest value, which means that sine theta is equal to 0, and theta is an integer multiplied by pi, n pi, pi, 2 pi, 3 pi, 4 pi, and so on and so forth. And these will produce the least values, which is 0. Now for d, we need to find the rate of change of x when theta is 30 degrees. We just have to plug in sine 30 degrees in our equation. So it's negative 600 pi times sine 30. And according to the reference triangle, sine 30 is opposite over hypotenuse, so it's 1/2. So we basically multiply negative 600 pi by 1/2, which is negative 300 pi centimeter per second. We will do the same thing for theta equal to 60 degrees. We will replace in how function of theta sine theta by sine 60 degrees. And 60 degrees is a special angle. Sine 60 is equal to square root of 3 over 2. We divide negative 600 by 2, we get negative 300 pi square root of 3 centimeter per second.